Hey folks, thanks for coming back. This is round 2 and we're going to be doing a project and let's see, it's in Days Java, that's the folder I want. I'm going to call this variables because this lesson will be on variables. And I'm going to make a new class, variables. Again, don't worry about abstract class interface, applet, unit test, or enum. You're not going to have to worry about that. So just like before, I'm going to basically wipe out all this stuff because I don't care about it for right now. I do need to know that I need a public, static, void, main, string, args. I need the starting bracket and ending bracket. Alright, so this is a lesson about variables. And it is really important that you use variables, and it won't be so obvious right now, but trust me please, you need to know variables. And it's not that hard, and it's not nearly as scary as the word variable in algebra class. Before we talk about variables, let's just talk about the data types in Java. So there are 8 different data types. You can have what's known as an int, which is really an integer. By the way, what I'm typing right now is actually not going to be code that can be processed in Java, but I'm just doing this as kind of a canvas for you right now. So you can have an int. You can, and an example of an int would be something like, you know, if an integer, a whole number. So it could be -6, it could be -85, 30, 83, 50, or whatever. It can be 10,000, and you actually don't need the comma. So int means integers, and this is the most common thing because when someone asks you your age, you don't say, well, I'm 13.25 or I'm 19.76. You usually say I'm 18, I'm 19, whatever. So integer is a very common variable that we will be using. There's also the double, which is a decimal. An example would be -6.5, or it could be something like 67.8. So that's a double. And it's basically just a decimal. Again, it can go positive and negative, and you can look up how big the numbers can be. Like double, there's something called float, which is also a decimal. The difference is float can be twice as big. So we actually don't use float too much because we don't care about it. For the stuff that we're doing right now, the numbers in double are fine. So float is basically just like a double on steroids. And in the same vein, you can have a long, which would be like so longs and ints are the same. It's just that long can be a lot bigger, so we actually don't use long. And float is like double, except we don't use float because it's more memory than we actually need. You can also have something called a byte, which we don't ever use, and don't. If you want to find out what that is, you can Google it. One of the other primitive data types is what's known as a char, and that would be a letter. And this is how you would express it in single quotation marks. So a char, and we actually do use those from time to time, will be just one letter. It could also be a number. It's actually a char is basically anything you can type. Any button on your keyboard, for the most part, would be a char. There's also the notion of a Boolean, which is or false. That's the only state. And we'll actually be using Booleans quite a bit too. So these are the 4 that you'll use a lot: int, double, char, Boolean. And there's also one other one that we won't be using, and I'm going to put it up here with byte, and that's called short. So that's just something else. Again, you can Wikipedia that, Google that if you're concerned. So those are the 8 primitive data types, but we will be using int, double, char, Boolean. Let's talk about how to define them. So let's say that you were writing a program, be asking someone their age. You would say int age equals, and in my case, I would say 37. And then I can do System.out.println or print line, your age is 37, which would output your age is 37. If you don't believe me, your age is 37. And that's not surprising because we literally printed out your age is 37. But I can also put the word age there because right now age is interchangeable with 37. So now when I compile it, if I were to run it again, it would say your age is 37. So now I can change this here. I just changed that to 67, so when I compile that. So that's one of the reasons why you want to have variables, so it's easy to change things later on. So imagine that you have 4,000 lines of code. This particular line could be, line number 3,998, and this can be line number 2, so it's very easy to change the state of age. Now, this is going to be a little bit more powerful once you start learning how to get things from the user, but I just want to show you some ways to define variables right now. So I'm just going to leave this back at 37. You can call a variable anything you want. In fact, I'm going to make this a double. It's not great to call a variable anything you want. Usually you want it to be descriptive because if you're reading the code and you haven't written the code, so if you're reading my code, you'd say, oh, age, I get that. That's probably the age of user or the age of the software designer or something like that. Anything you want is meaningless, and even more meaningless is your name. That has, even though this would work, I could write Dave Gadoo. Even though that will work and it will output, in this case, your age is 6.8. So you're better off calling a double something like height. If you're looking for your height, and my height is actually not 6.8 feet, but I'm probably closer to 5.8. Actually, I'm closer to 5.75. So now the code is a little bit more readable because the name, age, and height makes sense. And if you were finding the area of a triangle, your variable names might be base and height. Or if you're finding the area of a circle, it might be radius. So just make sure that your variable names make sense. For the most part, you can call it whatever you want. You can actually capitalize them, but don't. That's not how we do things in Java. Variable names should always be lowercase. It should start with lowercase. Now, if you want to do like radius of circle, and I alluded to this in one of the previous videos, you should use camelback writing, where you jam all the words together and capitalize the first letter of each word, except for the first one. Also for variables, you can have numbers in the variable name. You actually can't start a variable. That's bad news right there. You can't start a variable with a number, but you can have a number in it. And that comes up from time to time. And the last thing that you should know about variables, let's do int again. Maybe we're making software to compute grades in a grade book. It's not cool to, instead of number of grades, to name it main. The reason it's not cool to name it main is because, well, this function happens to be named main, but also because things like main, int, float, and again, this is where the name of the variable will go, final, these are all reserved words in Java. So if you try naming a variable something that's a reserved word, and I think in your reading it showed you that there's probably like 60, 65 some odd reserved words, and it was in one of the lessons. If you try and name a variable that's one of those 65 words, bad things happen. So you could do final 2, that would be fine, but final you can't do. And most compilers, most IDEs, including BlueJ, will highlight the text if it's a reserved word. Another reserved word would be while. And it's doing all sorts of funky things. So I actually went to high school with a kid named Chris Weil. I could not use his last name as a variable name, although I could do while 2, and that's perfectly fine. So I could output while 2, and then it would work. While we're doing this, and I hope that gives you a little bit of insight, there's more than one way to create variables. You can actually do like int x, y, z equals 10, and that can define 3 variables. All 3 of them are declared x, y, and z, and z is worth 10, x and y don't have values quite yet. So I could later on assign X to have a variable. So if you were the compiler and you were reading this code, you'd say, okay, first line, int x, y, z. X is declared, that's an integer. Y is declared, that's an integer. Z is declared, it's an integer that's worth 10. X equals 11, that's the next line. Okay, so now X is worth 11. I still don't know what Y is, and Z is 10. So let's output these. X equals X. Now, this plus sign doesn't mean add, it just means in addition to outputting everything that's in these quotation marks, also output the state of X. So let me just run this right now. X is 11. All right. In addition, I'm going to write Z equals, and then the state of Z. Now, if I was actually doing this, I would put a space here. But let me show you what happens if you don't put a space. Because anything in between quotes is actually what is typed up on the screen. So right now it's going to say System.out.println X equals and the state of X, which is 11. Z equals space and then the state of Z. So when I compile this, X equals 11, Z equals 10. Now, that's not, it actually is quite ugly that way, which is why I would recommend, pro tip, put a space there. If you put that space there, then when you run it, it'll actually have a space. And it looks a little bit prettier that way. So that's what the space does, is because it outputs X, which is 11, and then it will output space, Z equals space. Now, here's the wonky part. I don't know what the state of Y is because we haven't declared it yet. So in other words, we know Z is worth 10 because of this assignment right here. We know that X is worth 11 because of that assignment. We never said what Y was. So this is going to be very interesting what happens. And I guess I do have a typo there. Okay, so now this is going to output X equals the state of X, Z equals the state of Z, Y equals the state of Y. I have no idea what's going to happen. Oh, variable Y might not have been initialized. Phew. So Java in this case has stopped me. Now it won't always stop you and say, "Ooh, careful." So what I'm going to do is say, "Ooh, Y equals X, Z plus X." Ooh, Z plus Z. That's actually legal. We can do that, but I'm going to do this. Z plus X. So now, write down your answer on a piece of paper. This is the play along at home version. X equals 11, Z equals 10, Y equals 21. I guess that makes sense because we said Y was equal to the value of Z plus the value of X. So that is a brief primer into variables. There is one type of variable we didn't really talk about, and it's not actually a primitive data type, but we often use it as a primitive data type. And that's called a string. So the way that strings work is a whole bunch of things in letters, numbers, whatever, in quotation marks. So we could do System.out.println your name is name. Alright, so this should output on the screen now. Here's the compiler. Okay, string name, so I know a variable that's known as name. And then the next line is System.out.println, which means throw it up on the screen. I'll literally say your name is space, and then the value of name. Alright, so that hopefully that's what the compiler will do. Your name is Dave Gadoo. And again, changing the state up here will change the result here. So that's variables. Mostly primitive data types, except string is not really a primitive data type. It's not like int, double, char, or boolean. It's a different breed. It's not a primitive data type. It's actually a class, but we use it as a primitive data type. So just remember that to declare variables, you type their data type, and then you type the name that you'll be calling it.